Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on proportion. And we're going to be looking at practice questions that involve direct proportion and inverse proportion. If you need any extra help on direct proportion or inverse proportion, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 254 and also video number 255, there's dedicated video tutorials there on direct proportion and inverse proportion. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at our first question, question number 1. So question number 1 is, y is directly proportional to x. And when y is equal to 30, x is equal to 2.5. And we've been asked to work out the value of y whenever x is equal to 4. Okay, so let's have a look at this question. So let's start off with what we've been told. We've been told that y is directly proportional to x. So let's write that statement down. We've got y is directly proportional to x. So we've got y, the proportionality symbol, and then x. Okay, now what we want to do is we want to replace the proportionality symbol with the constant of proportionality k. So instead of writing y is proportional to x, we're going to now write y is equal to k times x, where we've got x and we're multiplied it by some constant of proportionality k. Okay, so whenever you want to get rid of that proportional symbol, you then put in your equals and then multiply what it's proportional to by k. Okay, now we're told some information here so we can work out what k is, because we know whenever y is equal to 30, x is equal to 2.5. So let's substitute those in and find out what k is. So y, that's 30, is equal to k, so that's k, multiplied by x, which is 2.5. And then if we divide both sides of that equation by 2.5, we'll divide by 2.5 and divide by 2.5. And remember, this is a non-calculator question, so we're going to need to do that division in our head, or on paper. And we've got here on our right-hand side, we've got k times 2.5. We're dividing by 2.5 to get rid of the times by 2.5, so we're just going to be left with k there. And then on the right-hand side, we've got 30 divided by 2.5. Now I know that 10 2.5s is 25, and then let's count up in 2.5s after that, so then 27.5 and 30, so that'll be 12 altogether. So 30 divided by 2.5 is 12. If you wanted to, you could use the bus shelter method. So what we're going to do is, rather than doing 30 divided by 2.5, we're going to multiply both of those by 10 to get 300 divided by 25. And then we can do 300 divided by 25, and that'll give you the same answer. If you do 300 divided by 25, you'll get the same answer as 30 divided by 2.5, because we're multiplying both the number we're dividing and the number we're dividing by, both by 10. So here, how many 25s go into 3? 0 remainder 3. How many 25s go into 30? That's 1 remainder 5. And how many 25s go into 50? That's 2. So as you can see, the answer is 12. And that's why 30 divided by 2.5 is 12. And here, that's why we had here k is equal to 12. So that's fantastic. We've now worked out what the constant of proportionality is. So we can now substitute that back into here. And that gives us our formula that y is equal to, and instead of k, we're going to write 12, the constant of proportionality, times x, or just x. So that's the formula there, y is equal to 12 times x. So in the question, we're asked to work out the value of y whenever x is equal to 4. Now you can just substitute that back into here, and you're going to get that y is equal to 12 times 4, and 12 times 4 is equal to 48, so y is equal to 48, and that's it. So we've worked that out. Okay, let's have a look at our next question, question number 2. Okay, question number 2. Question number 2, we're told that y is directly proportional to the square of x. So this time, rather than it just being y is proportional or directly proportional to x, we've this time got the square of x. Then we're told a pair of information. We've got that whenever y is equal to 24, x is equal to 12. And then we've been asked to find y whenever x is equal to 4. Okay, so let's start off with the statement. We're told that y is directly proportional to the square of x. So we've got y is proportional to the square of x, that's going to be x squared. So here we've got y is proportional or directly proportional to x squared, and that's it. Okay, so now we want to get rid of this proportionality symbol, so we're going to replace it with the constant of proportionality k. So we're going to times whatever this is by k. So we're going to have y is equal to, and if you times x squared by k, you'll have k x squared. Some students like to write k times x squared. That's totally fine, because you're going to find out what k is anyway. But I'm just going to write it like that. Y is equal to k times x squared. Okay, now we're told a pair of values here, that whenever y is equal to 24, x is equal to 2. So if we substitute those in, we'll be able to find out what k is. So let's substitute them in and see what we get. So instead of y, we've got 24 is equal to k, the constant of proportionality, multiplied by x squared. And x is equal to 2, so that's 2 squared. Okay, so we've now got that 24 is equal to k times 2 squared. Now we know that 2 squared is equal to 4, so we're going to have 24 is equal to k times 4. And then if we divide both sides of this equation by 4, we're going to get that k is equal to 6. So that's fantastic. We've found out what the constant of proportionality is. And we can substitute that back in here, the value for k in there, and we'll get that y is equal to 6x squared. So that's the formula we're going to be using in this question. And sometimes in the question you'll be given a value of x like we've been given here, which is 4, and we're going to substitute that in to find out what y is. In other occasions you might be told what y is, and then you have to substitute that in and then solve the equation to find out what x is. Okay, so let's work this out. So we've been asked to find the value of y whenever x is equal to 4. So we've got y is equal to 6x squared. X is equal to 4, so we're going to have y is equal to 6 times 4 squared. Remember, we need to do the squaring before we do the times in by 6, our order of operations. So y is equal to 6 multiplied by 4 squared is 16, and then 6 times 16 is 96. So that means that y is equal to 96, and that's it, we've solved that question. So y is equal to 96. Okay, let's look at our next question, question number 3. Okay, let's have a look at our next question, question number 3. So question number 3 says the cost of a circular table is directly proportional to the square of its radius. And the circular table with a radius of 40 centimetres costs £50. And we've been asked, what is the cost of a circular table with a radius of 60 centimetres? Okay, so let's have a look at the information we were told to begin with. So let's have a look at this first sentence. The cost of a circular table, so let's call that C, is directly proportional to, and then we've got the square of its radius, so the square of the radius, so r squared. So we've got here the cost is directly proportional to the radius squared. Okay, so let's get rid of this proportionality symbol and put in the constant of proportionality. So we're going to multiply the r squared by k. So we're going to get that c is equal to k r squared, or k times r squared. Okay, next we've got some information here. We're told that when the radius is 40 centimetres, the cost is £50. So let's substitute that in. The cost is £50, that's 50, is equal to the constant of proportionality, so that's what we're trying to find out, multiplied by the radius squared, so that's going to be 40 squared. And 40 squared, 40 times 40 is 1,600. It's a calculator question, so you can just type that into your calculator if you wanted to. So we've got £50 is equal to k multiplied by 40 squared, which is 1,600. Now we're going to divide both sides of the equation by 1,600. So 50 divided by 1,600 is equal to 0.03125, or 1/32, and that's equal to k. So that's great, we've got the constant of proportionality. K is equal to 0.03125, or k is equal to 1/32. Okay, so that's fantastic. We've now found the constant of proportionality, and we can substitute that back into this formula here. So we get that the cost is equal to the constant of proportionality, which is 1/32, or 0.03125. I'm going to use 1/32, okay, so 1/32, multiplied by the radius squared. And that's fantastic. We've now got the formula that we can use to work out the cost of any table. So here we've got the radius is 60 centimetres, so if we substitute that back into this formula, we're going to get that C, the cost, is equal to 1/32 multiplied by 60 squared. And let's just work that out. Let's get our calculator and type that in, and we get that the cost is equal to 112.5, or £112.50. So the answer is £112.50. And that's it. Okay, let's have a look at our next question, question number 4. So question number 4 says the time taken, t seconds, that it takes for a water heater to boil water is inversely proportional to the power, p watts, of the water heater. So the time taken is inversely proportional to the power of the heater. And we've got that whenever p is equal to 2000 watts, the time is equal to 252 seconds. And we've been asked to find the time to boil water whenever the power is equal to 800 watts. Okay, so let's go back up and look at this information. So we're told the time taken, and that's given to us as capital T, so T is inversely proportional to. So when we do inversely proportional to, we do the proportionality symbol like before, and then instead of just writing p, we're going to do 1/p. That's inversely proportional to. So when it's inversely proportional, we do 1/, and then what comes next. So inversely proportional to the power, so it's going to be 1/p. Okay, so here we've got that the time taken is inversely proportional to the power. Okay, now let's get rid of the proportionality symbol. So the time taken would be equal to, and then we're going to multiply this, what's on the right hand side, by k. And when we multiply this by k, the k would go on the numerator. For instance, if you had 1/p and you multiply that by k, well, it's going to be k/1. If you times the numerators and times the denominators, you're going to get 1 times k, which is equal to k on the numerator, and p times 1 is equal to p. So I'm just going to replace the 1 with the constant of proportionality. So we've got k/p. So So that's fantastic. So now we can substitute in this information to find out what k is, the constant of proportionality. So we've got the power is 2000 and the time is 252. So 252 is equal to k, the constant of proportionality, divided by 2000. And then if we multiply both sides by 2000, we're going to get the k is equal to 252 multiplied by 2000 is equal to 504,000. So that's fantastic. We've now got the constant of proportionality. So if we put that back into our formula here, we're going to get that the time taken is equal to 504,000 divided by the power. And that's great, because now if we know what the power is, we can work out the time taken. So the question says, find the time it takes to boil water whenever the power is equal to 800 watts. So we're going to substitute the 800 into here, and we're going to get that the time taken is equal to 504,000 divided by 800. And when we do that, we get an answer of 630. So the time taken would be 630 seconds, and that's it. So let's write that down, 630 seconds. So our answer is 630 seconds. Okay, let's look at our next question, question number 5. Okay, so question number 5 says that h varies directly to the cube of c. So whenever we see varies directly, it just means directly proportional to. So it says that h is directly proportional to the cube of c. It's just another way of writing it. So here we've got the h, it varies directly to the cube of c. So we've got h, so let's write that down. Varies directly, which means directly proportional to, so let's put the proportionality symbol down, and the cube of c, so that's going to be c cubed. So that's great, we've got h is directly proportional to c cubed. So let's get rid of our proportionality symbol. So we've got that h is equal to, and we're going to multiply what's on the right hand side by k. So we've got k times c cubed. So we've got h is equal to k times c cubed. Now we want to find out what k is, because in the question we've been asked to express h in terms of c. So we just want to find out what the formula is, and we're told some information. We're told that whenever h is equal to 40, so 40 is equal to k multiplied by c cubed, so that's going to be 2 cubed. And 2 cubed is 8, so we get that 40 is equal to k times 8. And if we divide both sides by 8, we get that k is equal to 5. So that's great. We can now write down what the formula is. If we put the 5 back in here, we get that h is equal to, and instead of k, it's going to be 5 c cubed. So that's our formula. Our formula is that h is equal to 5c cubed. So expressing h in terms of c would be h is equal to 5c cubed. And then if we go on down to part B says find the value of h whenever c is equal to 5. So we're going to substitute 5 into this formula, that h is equal to 5 times c cubed. But c is equal to 5, so we've got that h is equal to 5 times 5 cubed. 5 cubed is 125, times 5 is 625, so h is equal to 625. So that's it, 625. And then if we go on down, part C says find the value of c whenever h is equal to 5,000. So the formula was that h is equal to 5 times c cubed. Now we're told that h is 5,000, so we've got 5,000 is equal to 5 multiplied by c cubed. And then if we just solve this equation, we'll find out what c is. So if we divide both sides by 5, we're going to get that 1,000 is equal to c cubed. And then if we do the cube root of both sides, if we do the cube root of 1,000, that's equal to 10. So that means that c is equal to 10. And that's it, c is equal to 10. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 6. So question number 6 says the force F newtons exerted by a magnet on a metal object is inversely proportional to the square of the distance. And whenever d, the distance is equal to 2 centimeters, the force is equal to 50 newtons. And part A says find F in terms of d. So in other words, with this question, as the distance between the magnet and the object is increased, the force will decrease. And that makes sense, so it's inversely proportional. So here we've got the force, so I'm going to write down F is inversely proportional to, so we're going to put down the proportionality symbol, and because it's inversely proportional, we're going to do 1 over, and then the square of the distance, that's going to be d squared. So the force is inversely proportional to the distance squared. Okay, now we're going to get rid of the proportionality symbol and put the constant of proportionality on the numerator here, because we're multiplying the right hand side by k. So we're going to get that F is equal to k over d squared. And we want to work out what k is, because then when we work out what k is, we've expressed F in terms of d. So we're told some information here. F, which is 50, so 50 is equal to k divided by d squared, and d is equal to 2, so it'll be 2 squared. So we've got 50 is equal to k over 4, because 2 squared is 4. And then if we multiply both sides by 4, we're going to get that k is equal to 200. So that means that k, the constant of proportionality, is equal to 200. So it means that F is equal to 200 divided by d squared. And that's it. So we've expressed F in terms of d, 200 divided by d squared. Okay, and then if we go on down to part B says find the force when the distance between the magnet and the metal object is 10 centimeters. So we're going to substitute in 10 for the distance. So we're going to have that F is equal to 200 divided by D squared. D is the distance, that's going to be 10 squared, so F is equal to 200 divided by 10 squared. 10 squared is 100, so F is equal to 200 divided by 100, and that's equal to 2. So that means the force would be 2 newtons. And then part C says find the distance between the magnet and the metal object when the force is 8 newtons. So the formula is F is equal to 200 divided by D squared. The force is 8, so it's going to be 8 is equal to 200 divided by D squared. Let's multiply both sides of the equation by D squared, so we're going to get that 8D squared is equal to 200. Then if we divide both sides by 8, we're going to get that D squared is equal to 25, because 200 divided by 8 is 25 by halving it, halving it, and halving it again. And then finally, we're going to work out what D is. Now here's the distance, so it's only going to obviously be the positive value, so we can square root 25, and we're going to get that's equal to 5, so the distance would be equal to 5 centimeters, and that's it. Okay, and then if we go down to part D says explain what happens to F whenever the distance is halved. Well, that's actually quite nice, because actually part B and part C, we've got in part B, the distance was 10 centimeters, and in part C, we found the distance to be 5 centimeters. So let's write that down. So when the distance was equal to 10 centimeters, the force is equal to, and let's find out what that is. And when the distance is equal to 5 centimeters, then the force is equal to such and such, and then we'll be able to see what happens to the force. So whenever the distance is 10 centimeters, the force is 2 newtons, so the force is 2. And when the distance is halved and becomes 5 centimeters, the force goes up to 8 newtons. So actually, when the distance is halved, the force is 4 times larger. So it's times by 4, it's 4 times larger. And that's it, so let's write that down. When the distance is halved, the force is 4 times larger. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at our next question, question number 7. So question number 7 says the table shows a set of values for x and y, and y is directly proportional to the square root of x. So y is directly proportional to the square root of x. So we've got that y is equal to the constant of proportionality times the square root of x. You can put the multiply by sign there if you want to, but remember we're just multiplying the right hand side here by k, the constant of proportionality. Now let's substitute in the values we've been given, that we've got y, which is 9, is equal to k multiplied by the square root of x, so multiplied by the square root of 16. The square root of 16 is 4, so we get that 9 is equal to k times 4. And then if we divide both sides of the equation by 4, we get that k is equal to 2.25, or 9 quarters. Okay, so now let's write down what the formula is. We've got y is equal to 2.25 times the square root of x. Now we want to find out what x is here, so let's substitute in the value 54 for y. So we've got 54 is equal to 2.25 times the square root of x. Now if we divide both sides by 2.25, so 54, and it's a calculator question, 54 divided by 2.25 is equal to 24, so we get that 24 is equal to the square root of x. And that means to find out what x is, we just need to square 24. So 24 squared is equal to 576. So that means that x is equal to 576. And that's it, 576. We've completed the table. Okay, let's look at our next question, question number 8. So question number 8 says that a and b are positive numbers, and a is inversely proportional to b. So a is inversely proportional, so I've written a, the proportionality symbol, and then 1 over b, because it's inversely proportional to b, so I've just done 1 over b. And then we're told that whenever a is equal to 4, b is equal to 36, and we've been asked to find the value of a whenever b is equal to a. Okay, so we've written down what we've been told so far, that a is inversely proportional to b. Now let's get rid of the proportionality symbol by multiplying the right hand side by k, the constant of proportionality. So a would be equal to, and we'll just put k on the numerator, over b. So we've got a is equal to k over b. Now we're told some information. We're told that whenever a is equal to 4, b is equal to 36. So we've got a, which is equal to 4, is equal to k divided by 36. And then if we multiply both sides of the equation by 36, we're going to get that k is equal to 144. So that's great. We've now got our formula that a is equal to 144 divided by b. Okay, so we found the formula. Now the question says find the value of a whenever b is equal to a. So b is equal to a, so let's substitute that in. So we've got that a is equal to 144 over a, just replacing b by a. Now let's solve this equation and find out what a is. So we're going to multiply both sides of the equation by a. So we're going to multiply the left hand side by a and the right hand side by a to get rid of this divide by a. A times a is a squared, and on the right hand side of the equation we're just going to have 144. And now because we know they're both just positive values, we can square root 144 and you're going to get that a is equal to 12. So it means that a is equal to 12, and that's it. And let's just check that. If we have a is equal to 144 divided by b, whenever a is equal to 12, if you solve that, you'll find that b is equal to 12 as well, and that means that b is equal to a, and that's it. Okay, let's look at our next question, question number 9. Okay, question number 9. Question number 9 says c is directly proportional to the square root of y. So c is directly proportional to the square root of y. And whenever c is equal to 12.8, y is equal to 16, we've been asked to express c in terms of y. So in other words, we want to find the formula. So we've got the c is directly proportional to the square root of y. So let's get rid of the proportionality symbol and write that c is equal to, and multiply the right hand side by k, so that'd be k times the square root of y. Now let's substitute in our values. So 12.8 is equal to k times the square root of 16. The square root of 16 is 4, so we're going to get that 12.8 is equal to k times 4. And then if we divide both sides by 4, 12.8 divided by 4 is equal to 3.2, so k is equal to 3.2. And you can just substitute that back into here, and you get that c is equal to 3.2 times the square root of y. And that's it, c is equal to 3.2 times the square root of y. Okay, and then if we go on down to part B says find c whenever y is equal to 400. So we're going to substitute now 400 into the formula. We have the formula c is equal to 3.2 multiplied by the square root of y. Whenever y is equal to 400, we're going to get that c is equal to 3.2 times the square root of 400. And the square root of 400 is 20. So we get that 3.2 times by 20 is equal to c. And when we do 3.2 times 20, you can times by 10, which is 32, and times by 2, which would be then doubling it, which would be 64. So c is equal to 64, and that's it. Okay, let's look at our next question, question number 10. Okay, question number 10. Question number 10 says the time taken, t, for passengers to be checked in for a flight is inversely proportional to the number of staff working. So that makes sense. The more staff that they be working, the less time it would take for the passengers to be checked in for the flight. And it takes 30 minutes for the passengers to be checked in whenever 10 staff are working. We've been asked to find an equation connecting t and s. So the time taken is inversely proportional to, so let's put the proportionality symbol down, and it says inversely, so 1 over, and then it says the square of the number of staff working, which is s, so s squared. So we've got that t, the time taken, is inversely proportional to the number of staff squared, or s squared. Okay, now let's get rid of the proportionality symbol. So t is equal to, and then we're just going to put the k on the numerator here because we're timesing this right hand side by k, over s squared. Okay, so we've got the t is equal to k divided by s squared. And if we work out what k is, then that would be our equation. So t's the time taken, which is 30 minutes, is equal to k, the constant of proportionality, divided by the number of staff working squared. So it's going to be 10 squared. 10 squared is equal to 100, so we've got 30 is equal to k divided by 100, and then if we multiply both sides by 100, we're going to get the k is equal to 3000. So that's great. We can now substitute that back in here. That'll give us our equation that t is equal to 3000 divided by s squared. Okay, then if we go on down to part B says what's the minimum number of staff that must be working so that the time taken is under 60 minutes. So we want the time taken to be under 60 minutes. So let's have a look at our equation. So we've got the time taken is equal to 3000 divided by s squared. Okay, so we want the time to be under 60 minutes. I'm just going to let the time be equal to 60 minutes and see what we get for the number of staff there. So if the time's equal to 60, we're going to get that 60 is equal to 3000 divided by the number of staff squared. And then we're going to multiply both sides of the equation by s squared. So we're going to get 60 s squared is equal to 3000. We're then going to divide both sides of the equation by 60 to get that s squared is equal to 50. And then finally, we're going to square root both sides of the equation. And that means that s would be equal to the square root of 50, which is equal to 7.071067, and so on. And that means that for the time taken to be exactly 60 minutes, we would need 7.07 and so on staff. Now, first of all, we can't actually have that amount of staff. And second of all, that would be 60 minutes. We want it to be under 60 minutes. So that means we need to increase this. We need to round it up. So we're going to need 8 members of staff. And that's it. Another way you could do this question is actually use just trial and error and substitute in values for S. So you could do 3,000 divided by 2 squared. So if there's 2 members of staff, that'll be 750 minutes. You could change the number of staff to perhaps 6, and then that'll be 83.3 recurring minutes. You could change the number of staff to be 7, and then you get that's equal to 61.22 minutes. And then you could change it to 8, and you'll find that's equal to 46.875 minutes. So you can see that once you go to 8 members of staff, the time taken would be under 60 minutes. And that's it. Okay, let's look at our next question. Okay, so let's have a look at our next question, question number 11. So question number 11 says, the cost of a trip is directly proportional to the square root of the distance. So the cost is directly proportional to the square root of the distance. The cost is £495 when the distance is 324 miles. We've been asked to find a formula connecting the cost and the distance. Okay, so here we've got the cost is directly proportional to the square root of the distance. So that means if we replace the proportionality symbol with the equal sign, so C is equal to, and then let's introduce the constant of proportionality, so let's multiply this right hand side by K. So that's going to be K times the square root of D. And let's find out what K is, and then that will then be our formula once we substitute the value of K in. So we've got some information here. The cost is £495. We've got that's equal to K multiplied by the square root of 324. Now this is a calculator question, so we can do the square root of 324 in our calculator, and that's equal to 18. So 495 is equal to K times 18. And then if we divide both sides of the equation by 18, we're going to get that K is equal to, so K is equal to, we get that K is equal to 27.5. So that's fantastic. That means that we substitute that back into here, we're going to have that the cost is equal to 27.5 multiplied by the square root of D. And that's it. So that's the formula connecting the cost and the distance. Okay, let's look at our next question, question number 12. So question number 12 says W is inversely proportional to y squared. So W is inversely proportional to y squared. Okay, so that's fantastic. And actually, let's get rid of the proportionality symbol. So W is equal to K over y squared, just multiplying the right hand side by K, the constant of proportionality. Okay, now we're told some information here. We're told that whenever W is equal to 54, Y is equal to C. So whenever W is equal to 54, so 54 is equal to K divided by, and we're told that Y is equal to C. So Y is equal to C, so we're going to substitute in C for Y, so that'll be C squared. Okay, so that's great. And if we multiply both sides of the equation here by C squared, we're going to get that K is equal to 54C squared. Okay, so we'll find out what the constant of proportionality is in terms of C. So let's substitute that back into our formula. So we get that W is equal to K, which is 54C squared divided by Y squared. Then if we carry on with the question, we've been asked to find the value of W whenever Y is equal to 3C. So we're now going to substitute in 3C in for the value of Y. So we're going to get that W is equal to 54C squared divided by, and then Y, which is 3C, so 3C in brackets and then squared. So 3C squared, well 3C times 3C is 9C squared, so we're going to get that W is equal to 54C squared over 9C squared, because 3C times 3C is 9C squared, just squaring with the 3 and the C. And then if we do our division, we'll find out what W is. So C squared divided by C squared, that's 1, they're going to cancel out, and 54 divided by 9 is equal to 6. So that means that W is equal to 6, and that's it. So this question was just a bit different than the ones we've looked at so far, because we weren't told what Y was, we were told it was equal to C. But what we done was we just done the question in the same way. We substituted in the value for C in for Y. We found the constant of proportionality in terms of C, and then we put that in for the value for K. And then we substituted in 3C for Y, and we squared that to be 9C squared, and then we divided that, and we got that was equal to 6. And that's it. Okay, let's look at our next question, question number 13. Okay, question number 13. Question number 13 says A is directly proportional to the square root of C, and we're told that W is inversely proportional to A cubed, and then we're told that whenever C is equal to 49, A is equal to 35, whenever A is equal to 2, W is equal to 16, and we've been asked to find the value of W whenever C is equal to 4. Okay, so this time we've got two different relationships here. We've got that A is directly proportional to the square root of C, and we've got that W is inversely proportional to A cubed. So we've got two different relationships there. Okay, so let's start off with this one. We're told that A is directly proportional to the square root of C. And then if we have a look at here, we know whenever C is equal to 49, A is equal to 35. So let's substitute those in here. So actually, let's get rid of the proportionality symbol. So we've got that A is equal to K times the square root of C. So if we substitute in the values of A and C here, so A is equal to 35, so we get 35 is equal to K times the square root of 49. The square root of 49 is 7, so we're going to get that 35 is equal to K times 7. And then if we divide both sides by 7, we're going to get that K is equal to 5. So we've got K is equal to 5 there, and if we substitute that back in, we get that A is equal to 5 times the square root of C. So that's our first formula there. Now if we have a look at the other one, I'm just going to go back over to here. We know that W is inversely proportional to A cubed. So let's get rid of the proportionality symbol. All right, W is equal to K over A cubed. Just multiplying the right hand side there by K, or just putting it on the numerator. Now, let's substitute in the information we've been given that whenever W is equal to 16, we know that we're going to have K there over A cubed. So it's going to be A cubed. 2 cubed is equal to 8, so it's going to be 16 is equal to K over 8. And then multiply both sides by 8. 16 times 8 is equal to 128, and that's equal to K. So that means that our formula would be W is equal to 128 over A cubed. Okay, so that's our second formula. So we've got our two formulae there. Okay, so we've got our two formulae. Now, if we have a look at the question, we've been asked to find the value of W whenever C is equal to 4. So C is equal to 4. So we're going to substitute that into here. And whenever we do that, we'll then work out the value for A is. And when we work out the value for A, we'll then substitute that into here and find the value for W. So let's do that. So I'm just going to change color of ink here. So whenever C is equal to 4, we're going to have that A is equal to 5 times the square root of C. So it's going to be the square root of 4. So A is equal to 5 times the square root of 4. And the square root of 4 is 2. So we're going to get that A is equal to 10. So A is equal to 10. Now we're going to substitute that in here. So W is equal to 128 over 10 cubed. Just substituting the 10 for the value for A. 10 cubed is 1,000. So we're going to get that W is equal to 128 divided by 1,000. And then when we do 128 divided by 1,000, we're going to get that W is equal to 0.128. And that's it. So that's the value of W, 0.128. 0.128, or as a fraction, it would be equal to 16 over 125. But it's a non-calculator question, so that's how I would have done that question there. And that's it. So W is equal to 0.128. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 14. So question number 14 says the number of days, D, to complete research is inversely proportional to the number of researchers R working on it. And research that takes 125 days to complete has 16 people work on it. We've been asked to find out how many people are needed to complete research in 40 days. So we know the number of days, D, is inversely proportional, so inversely proportional to the number of researchers working on it, R. So we've got that D is inversely proportional to R. So now let's get rid of the proportionality symbol. So we're going to write that D is equal to, and we're going to times this by K, so we're going to get K over R. Okay, so we've just times this right hand side by K. So now let's find out what K is. So let's use the information we've been given. So the number of days is 125, and that's equal to K divided by R, the number of researchers, which is 16. Now if we times both sides by 16, this is a non-calculator question, so we're going to need to do 125 times 16. So 6 times 5 is 30, put a 0 down, carry our 3. 6 times 2 is 12, plus 3 is 15, put a 5 down and carry a 1. And 6 times 1 is 6, plus 1 is 7. So we've times by 6, now let's times by 10, so put a 0 down, and then we would have 5, 2 and 1, and then if we add them up, 0 plus 0 is 0, 5 plus 5 is 10, put a 0 down and carry a 1. 7 plus 2 is 9, plus 1 is 10, put a 0 down and carry a 1, and 1 plus 1 is equal to 2. So that means that K is equal to 2,000. So that means that D is equal to 2,000 divided by R. Okay, now the question says, find how many people are needed to complete the research in 40 days. So D is equal to 40. So 40 is equal to 2,000 divided by R. Now you might be able to look at this and say, well, what do we divide 2,000 by to get 40? And the answer would be 50. 2,000 divided by 50 is equal to 40. Or we can times both sides of the equation by R to get 40R equals 2,000. And then we're going to divide both sides of the equation by 40. So if we do 2,000 divided by 40. Let's see what we get. So how many 40s go into 2? 0 remainder 2. How many 40s go into 20? 0 remainder 20. How many 40s go into 200? That's 5. And how many 40s go into 0? That's 0. So the answer would be 50. So that's it. So R is equal to 50. And the number of researchers needed to complete the research in 40 days is 50. Okay, let's look at our next question, question number 15. So question number 15, this is on the proportionality graphs. So we've been asked to match each graph to the correct relationship. So it's important to know what the proportionality graphs look like, and I highly recommend you go to Corbettmaths and watch the video on proportionality graphs. Here we have got our three graphs and our three relationships. So I'm going to start off with this one. Y is directly proportional to x. So it means as x increases, y increases, and it'll be this graph here. As x increases, y increases. So that's that graph there. Okay, now let's have a look at this graph here. Well, that's going to be this relationship here. This is the inversely proportional to relationship. We've got y is inversely proportional to x. As x increases, y decreases. So as x increases, y decreases. So that's that graph there. And then finally, this one here, we have got, this looks like the square root graph, y is the square root of x. And as you can see, that would be this relationship here. Y is directly proportional to the square root of x. So that's it. That's that graph there. Okay, let's have a look at our next question, question number 16. Okay, let's have a look at our next question, question number 16. So question number 16 says that x and y are positive numbers and y is inversely proportional to the square of x. So y is inversely proportional to the square of x. So we've got y is proportional to 1 over x squared, or inversely proportional to x squared. And then we've got this table, so we know whenever x is equal to 2, y is equal to 30, whenever x is equal to 4, y is equal to a, and whenever x is equal to b, y is equal to 400. And we've been asked to find the values of a and b. Okay, so let's replace the proportionality symbol with the constant of proportionality. So y is equal to, and if we just times this side by k, we're going to have k over x squared. Okay, now we've got a pair of information here. We know that whenever x is equal to 2, y is equal to 30. So let's substitute those values in and find out what k is. So 30 is equal to k divided by x squared. Well, that's going to be 2 squared. And 2 squared is 4, so 30 is equal to k divided by 4. And if we times both sides by 4, we're going to get that k is equal to 120. Okay, so let's substitute that into our formula. So we're going to have that y is equal to 120 over x squared. So that's great. We can now use this to work out the values of a and b. Okay, so let's start off by finding the value of a. So whenever x is equal to 4. So if x is equal to 4, we're going to get that y is equal to 120 over 4 squared. And 4 squared is 16, so y is equal to 120 divided by 16. And 120 divided by 16 is equal to 7.5. So that means that a is equal to 7.5. Okay, now part B, I'm just going to change color of ink here to blue. Okay, now if we have a look at how we're going to find b, we've got y is equal to 120 divided by x squared. So we've got that y is equal to 120 over x squared, and we want to find the value of x whenever y is equal to 480. So let's substitute both of these into our formula. So y, that's 480, is equal to 120 over b squared. Just substituting in 480 for y and b for x. Okay, now let's multiply both sides of the equation by b squared. So we're going to have 480 b squared is equal to 120. And then if we divide both sides of the equation by 480, we get that b squared is equal to a quarter, or 0.25. And then finally, we just need to square root. I remember that we're told that a and b are both positive values, so we can just square root this and get that b is equal to, and the square root of a quarter is equal to a half. And it's a calculator question anyway, so you can work that out and you get that b is equal to a half. And that's it. So that means that a is equal to 7.5 and b is equal to 0.5, or a half. And that's it. So we found our values for a and b. So that a is equal to 7.5 and b is equal to 0.5, or a half. And that's it. Okay, let's look at our next question, question number 17. So question number 17, we're told that a and b are positive numbers and a is inversely proportional to the cube of b. And we're told that whenever a is equal to 10/27, b is equal to 30. We've been asked to find the value of a whenever b is equal to a. Okay, so let's start off by writing down this relationship. A is inversely proportional to the cube of b. So a is inversely proportional to the cube of b. Okay, now let's replace the proportionality symbol. So we're going to get that a is equal to k over b cubed, where k is the constant of proportionality, and let's work out what that is. And we're told some information here. We're told that whenever a is equal to 10/27, b is equal to 30. So let's substitute those both into this formula. So a is 10/27, and that's equal to k divided by b cubed, and that'd be 30 cubed, and 30 cubed is equal to 27,000. And now if we want to work out what k is, we just need to solve this equation. So let's multiply both sides of the equation by 27,000. So I'm just going to type into my calculator 10/27, so 10/27 multiplied by 27,000, and we're going to get the k is equal to 10,000. Okay, so that's great. We now know what the constant of proportionality is. So we can put that back into the formula. So we know that a is equal to 10,000 over b cubed. Okay, so now if we carry on with the question, we're told to find the value of a whenever b is equal to a. So b is equal to a, so we've got a is equal to 10,000 over a cubed. So we want to solve this, so let's times both sides of the equation by a cubed. So we're going to get a times a cubed would be a to the power 4 is equal to 10,000. And then if we want to work out what a is, and we're told that a and b are both positive numbers, so we can just work out the fourth root of 10,000. So if we just do the fourth root of 10,000, that's equal to 10. So that means that a is equal to 10. And that's it. So a is equal to 10. And that's it. Okay, let's look at our next question, question number 18. So question number 18, we've been given two relationships. We're told that w is inversely proportional. So it's inversely proportional to the square root of y, like so. And then I'm just going to change color of ink here to blue. We're also told that w is directly proportional to z cubed. So we've got our two relationships. I'm actually just going to get rid of the proportionality symbols in each of them and put in the constant of proportionalities. So here we'd have w is equal to k over the square root of y. And here we'd have w is equal to k times z cubed. Okay, so now if we carry on with the question, we're told that the ratio of w to y to z is equal to 3 to 2 to 5 whenever y is equal to 4, and we've been asked to work out the ratio of w to z whenever y is equal to 256. Okay, so let's start off with this information here. We've got the ratio of w to y to z to equal 3 to 2 to 5 whenever y is equal to 4. So we know this is the ratio whenever y is equal to 4. So if y is equal to 4, well, if we times that by 2, so we times by 2, we get that's equal to 4. That means that w would be equal to 6, and it would mean that z is equal to 10, just timesing both of those by 2. So whenever y is equal to 4, w is equal to 6, and z is equal to 10. So that means that we can work out the constant of proportionalities. So let's go back to this one. So we've got w is equal to k divided by the square root of y. So here we substitute these values in. 6 is equal to k over the square root of 4. And the square root of 4 is 2, so we get that 6 is equal to k divided by 2. And then if we multiply both sides by 2, we get that k is equal to 12. Put that back in, the formula would become w is equal to 12 over the square root of y. So that's fantastic. Now let's have a look at this one here. So we know that whenever y is equal to 4, w is equal to 6, and z is equal to 10. So let's go over here. We've got w, that's equal to 6, is equal to k times the cube of 10, so 10 cubed. And 10 cubed is 1,000, so you get 6 is equal to k times 1,000. And then if you divide both sides by 1,000, you're going to get the k is equal to 0.006. So that's great, and we can substitute that back in, so we get that w is equal to 0.006 times z cubed. So that's great. So we've now got our two formulae. So if we go back to the question, we've been asked to find the ratio of w to z whenever y is equal to 256. So let's let y equal 256 and substitute it back into here. And then we'll find out what w is, and then we'll take that value for w and put it in here and find out what the value of z is, and then we can find that ratio. Okay, so so I'm just going to change color of ink here. I'm going to say whenever y is equal to 256, we would have here w is equal to 12 over the square root of 256. And the square root of 256 is equal to 16, so we get that w is equal to 12 over 16, and 12 divided by 16 is equal to 3/4. W is equal to 3/4. Okay, so now we know that w is equal to 3/4. We can go here and we can say, well, 3/4, 0.75 or 3/4 is equal to 0.006 z cubed. And then if we divide both sides by 0.006, so 0.75 divided by 0.006, we get that 125 is equal to z cubed. And then if we cube root both sides, we're going to get that z is equal to 5. So that's great. We now know what W is equal to and Z is equal to. We can now make that ratio, because here we want to find the ratio of W to Z. Well, it's going to be 0.75 to 5. And actually, let's multiply both sides here by 100. So we get the ratio 75 to 500. And then if we cancel that down, we can divide both of them by 25. 75 divided by 25 is 3, and 500 divided by 25 would be equal to 20. So the ratio of W to Z would be 3 to 20, and that's it. So 3 to 20. Okay, let's have a look at our next question, question number 19. So question number 19 says W is directly proportional to x cubed. So W is directly proportional to x cubed. And that means that we'd have W is equal to K times x cubed. So we're replacing the proportionality symbol with the constant of proportionality. And we've been asked to find the percentage increase in W whenever x is increased by 10%. So if we increase x by 10%, what is the overall percentage increase in W? Okay, so if x is equal to, just say x, our answer would be K times x cubed. So if we increase x by 10%, we would use our multipliers, and if you increase something by 10%, you times it by 1.1 or 1.10. So that means that 1.1x would be what we would get if we increased x by 10%. So that means here, instead of substituting in our value for x, if we were to substitute in 1.1x, so if we increased it by 10%, we would have W equals K times, and then instead of x cubed, it would be 1.1x cubed, because we're increasing by 10%. Okay, then if we cube this, if we take our 1.1x and we cube it, well, we're going to cube the number. 1.1 cubed is equal to 1.331, and x cubed would be x cubed. So we'd have K, the constant of proportionality, times by 1.331 times by x cubed. So as you can see here, the difference between this and this would be the multiplying by 1.331. So that would be our overall multiplier for the increase. So then that would mean if you multiply something by 1.331, the percentage increase would be 33.1%. And that's it. So that's the overall percentage increase in W whenever x is increased by 10%. So that's one way to do this question. Another way to do this question would be just to say, well, if you're increasing by 10% and it's x cubed, well, you're just going to cube that multiplier. You're going to do 1.1 cubed. That's equal to 1.331. So overall, the percentage increase would be 33.1%. And that's it. Okay, let's look at our next question, question number 20. So question number 20 says A is directly proportional to the cube root of B. So A is directly proportional to the cube root of B. And then actually, let's just get rid of our proportionality symbol, put in K times the cube root of B. And then we're told that B is increased by 75%. So if you increase B by 75%, the multiplier would be 1.75. So if B is increased by 75%, we would have 1.75B here. And we've been asked to work out the percentage increase in A. Okay, so let's replace the B with 1.75B. So we'd have A is equal to K times the cube root of 1.75B. Okay, now here, what I'm actually going to do is I'm going to work out the cube root of 1.75 and then the cube root of B. So we'd have A is equal to K times, and let's do the cube root, so the cube root of 1.75, and that's equal to 1.2050711132 and so on, and then the cube root of B would just be the cube root of B. So as you can see, the only difference between this one and this one, whenever we increase by 75%, is this multiplier. So this multiplier would mean the overall percentage increase in A would be 20.507 and so on percent. So it's going to be 20.507 and so on percent. Another way to do this question is you can say, well, the multiplier would be 1.75. We're doing the cube root of it, so if we do the cube root of that multiplier, you'll get that's equal to 1.205 and so on. So you can then see the overall percentage increase would be 20.5 and so on percent. And that's it. Okay, let's look at our next question, question number 21. So question number 21, we're told that x is directly proportional to w squared, and whenever x is equal to 50, w is equal to 5. And then we're told that y is directly proportional to x cubed, and whenever x is equal to 3, y is equal to 4. And we've been asked to find the formula for y in terms of w and to give our answer in its simplest form. Okay, so let's go up to this one here. So x is directly proportional to w squared. So that's the relationship, and let's put in the constant of proportionality. So x is equal to kw squared, and then substitute in the values. So we're going to get that 50 is equal to k times 5 squared, And 5 squared is 25, so 50 is equal to k times 25, so k is equal to 2. So that means the formula here would be that x is equal to 2w squared. So that's our first formula. Now if we look at our next relationship, we've got that y is directly proportional to x cubed. So that means that y is equal to kx cubed. And if we substitute in our values, we're going to get that 4 is equal to k times x cubed. That's going to be 3 cubed. 3 cubed is 27, so we get 4 is equal to k times 27. And then if you divide by 27, we're going to get that k is equal to 4 27ths. And then if we substitute that into the formula here, we're going to get that y is equal to 4 27ths x cubed. That's our second formula. Okay, so now we've got our two formulae. The question says, find a formula for y in terms of w. So if we look at our formula here, we've got y is equal to 4 27ths x cubed. Now, this is in terms of x. We want it in terms of w's. But we know that x is equal to 2w squared. So we can substitute that into here and then work out our formula in terms of w. So let's do that. So here we'd have y is equal to 4 27ths, so 4 27ths. And then we've got x, but we're going to use 2w squared for that. So 2w squared. And then that is x cubed, so the little 3 there. So we're just replacing the x with the 2w squared. Now let's work out what this would be. So y is equal to 4 27ths. And then we're cubing this. So we're going to cube both of the things inside the bracket. So 2 cubed is equal to 8. And w squared cubed, well, we've got a power of a power here. So times the two powers together. So that'll be w to the power of 6. And then finally, we just need to simplify this or expand out our brackets. So y is equal to, and we're just going to take the 4 27ths and we're going to times that by 8. And that's equal to 32 27ths. And then we've got our w to the power of 6. And that's it. So that's our formula for y in terms of w. Y is equal to 32 27ths w to the power of 6. So what we done in that question was we found our two formulae. We then find that we had a formula for y in terms of x, but we wanted it in terms of w. So we replaced the x with what the x was equal to, which was the 2w squared. We then cubed that. So we cubed the 2 and cubed the w squared. Remember the power of a power, we times the two powers together. And then we just expanded the bracket. We just times the 8 by the 4 27ths and gave us 32 27ths w to the power of 6. And that's it. Okay, let's look at our next question. Let's have a look at our next question, question number 22. So question number 22 says, w is directly proportional to c squared. So w is directly proportional to c squared. And then we're told that whenever w is equal to 16, c is equal to 2. And we've been asked to find the value of c whenever w is equal to 28c minus 49. Okay, so here we've got the relationship. Let's replace the proportionality symbol with the constant of proportionality. So w is equal to k times c squared. Now, let's find out what k is by using this information. So 16 is equal to k multiplied by 2 squared. And 2 squared is equal to 4. And dividing by 4 gives us that k is equal to 4. So that means that we've got, if we put that back into our equation, we're going to get that w is equal to 4c squared. Okay, so that's fantastic. Now, if we go back to the question, we've been asked to find the value of c whenever w is equal to 28c minus 49. So this is what w is equal to. So let's substitute that into our equation, our formula. So here we've got 28c minus 49 is equal to 4c squared. Now let's solve this equation. So let's bring everything over to one side, and I'm going to bring everything to the right hand side here. So 0 is equal to 4c squared minus 28c plus 49. Okay, now let's factorize this. So 0 equals, and then bracket, 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 bracket. I'm going to try 2c and 2c and minus 7 and minus 7 and see if that works. 2c times 2c is 4c squared, perfect. 2c times minus 7c would be minus 14c, and another minus 14c would be minus 28c, perfect. And minus 7 times minus 7 is 49, great. So that means here if we solve this, we've got 2c minus 7 is equal to 0. Adding 7 to both sides gives us 2c is equal to 7. Dividing by 2 gives us c is equal to 7 over 2. And that's it. So that's fantastic. We found the value of c. It's equal to 7 over 2 or 3.5. And that's it. Okay, let's have a look at our last question, question number 23. So question number 23 says, w and x are positive numbers, and w is directly proportional to the square of x. And when the value of x is increased by 2, the value of w is 3 times larger. And we've been asked to work out the exact value of x. So we want to find the exact value of x. And whenever it's an exact value, that means not as a decimal number, but perhaps as a surd. So perhaps as 4 plus root 7 or something like that. Okay, so let's have a look at this question. W is directly proportional to the square of x. So let's write that relationship down. W is directly proportional to the square of x, or W is equal to kx squared. Okay, so we've got W is equal to k multiplied by x squared. Now we're told when the value of x increases by 2. So let's increase x by 2. So that'll be x plus 2, and then close brackets squared, and then times k. And that would be equal to, now obviously that'd be our new value for W, but we're told it's made 3 times larger. So here we have what W was, it's kx squared, and it's made 3 times larger. So instead of writing here 3w, I'm going to write here 3kx squared, just replacing the w with kx squared and timesing it by 3 because it's 3 times larger. So just to recap, when the value for x is increased by 2, the value of w is 3 times larger, and the value for w was kx squared, and we're just timesing it by 3. Now let's solve this equation. And the first thing I'm going to do is I'm going to divide both sides by the constant of proportionality. So they've gone, so that's great. So we've got 3x squared is equal to, and let's expand these brackets, x plus 2 multiplied by itself, x plus 2. So we've got 3x squared on the left hand side, and on the right hand side, x times x is x squared. X times 2 is plus 2x, plus another 2x, and then plus 4. And then if we simplify this, we'd have 3x squared on the left hand side is equal to x squared plus 4x plus 4. Just squaring that bracket. Okay, now let's bring everything to the left hand side. So we'd have, if we take away x squared from both sides, we'd have 2x squared. And then take away 4x from both sides, so it'd be minus 4x. And take away 4 from both sides would be minus 4, and that equals 0. And then if we divide everything by 2, we're going to get that x squared minus 2x minus 2 equals 0. We've got two different approaches that we could use here. We could use completing the square, or we could use the quadratic formula. And let's just do both for a bit of fun. So in terms of completing the square, we had x squared minus 2x minus 2 equals 0. To do completing the square, we're going to open up our brackets. Then we're going to half the coefficient of x. So the coefficient of x here is minus 2, so half of that is minus 1. Close brackets, squared. And then take away whatever this is squared. So minus 1 squared is 1, so we're going to take away 1. And then we've still got our minus 2, and that equals 0. Okay, now let's simplify this. So we've got x minus 1, close bracket squared, minus 3 equals 0. Let's add 3 to both sides. That'll give us x minus 1, close bracket squared, equals 3. Now let's square root. So on the left hand side, we'd have x minus 1. And then the right hand side, we're going to have plus or minus the square root of 3. And then finally, we're going to add 1 to both sides of the equation. So we're going to get that x is equal to 1 plus or minus the square root of 3, or x is equal to 1 plus the square root of 3, or x is equal to 1 minus the square root of 3. Now if we go back up to the question, we were told that x and w are positive values. Now here, x plus root 3, well that's going to be positive, so that will work. But here, x is equal to 1 minus root 3. Now the square root of 3 is bigger than 1, because obviously the square root of 1 is 1 and the square root of 4 is 2. So this is going to be 1 point something. And if we do 1 subtract 1 point something, that's going to be negative. So that solution isn't going to work, but this solution will. So that means the exact value of x would be 1 plus root 3. So that means that x is equal to 1 plus root 3. And that's our exact value for x. Okay, now we're solving it using completing the square. We can also solve it using the quadratic formula, so let's have a look at that now. Alternatively, like I mentioned, you could use the quadratic formula. You could let a equal 1 here. You can let b equal minus 2 and c equals minus 2. And then substitute them into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And then if we substitute the values into the quadratic formula, you're going to get x equals minus b, so b was minus 2, but it's minus 2, so it's going to be 2, plus or minus the square root of b squared, well minus 2 squared is 4, minus, and then I like to put this bit in brackets, 4 times a times c, so 4 times 1 is 4, times c would be times minus 2 would be minus 8, close brackets, that's all divided by 2 times 1, and that's 2. And then if we work this out, let's see what we get. So we'd have x is equal to 2 plus or minus the square root of 4 minus minus 8, well that's 12, because you're subtracting a negative, and then divided by 2, and then let's simplify the surd, so root 12 is equal to root 4 times root 3, The square root of 4 is 2, so that's 2 root 3, 2 root 3. So we've got that's equal to 2 plus or minus 2 root 3 over 2. And then finally, if you divide everything through by 2, you get x is equal to 1 plus or minus the square root of 3. And again, we've solved our equation and we've got x is equal to 1 plus root 3 or 1 minus root 3. But remember again, the x has to be a positive value. So 1 minus root 3 is not going to work, so that means that x will have to equal 1 plus the square root of 3. That's the exact value of x. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on proportion, so direct proportion and inverse proportion. If you need any extra help on proportion, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video numbers 254 and 255, there's dedicated video tutorials there on proportion. Alternatively, you can scan this QR code. But that's it. So I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. And if you know anyone else that might find the Corbettmaths website or resources useful, please recommend it to them. And that's great. Thank you. Cheers. Bye.